Hi, Praneeth. So we have Praneeth in the classroom, and then we have Arush, Nanya, Dheera, Jana, Neil, Nikhil, Riya, Ritika, Samriddhi, Sara, and Vivan. All right. So the kids are still missing, but I think we are good to get started. Arush, would you know where is Davik and Sahit?
No.
No? Okay, that's all right. So, if you look at what we have been doing, hello Saranya. So we were kind of getting tired of algebra, geometry, no, coordinate equations, system equations, whatnot. Then we talked about new circle, and then we moved on to the new topic. Not a new topic; it's a topic around problem solving and data analysis. That is where we started with a very easy looking topic: ratio, proportion, and rates. And we did some problem. And again, I have no shame in acknowledging that I did not teach you guys anything. But we looked at the kind of problems, we looked at some of the standard problems that you guys will come across relating to these topics. So my only request to you all would be, whenever I pick up a topic, now we are going to talk about percentage also. Whenever we pick up any topic, the topic itself might look easy, and obviously you guys will have come across these topics a lot more, but then don't go by the name of the topic, because the questions that you guys will come across would make all possible attempts, knowing you guys are in our senior grades. So the questions, even if it's relating to a topic that you have known for 5 years, the questions that will come across will have little more flavor, which will be aligning with your grades. Okay, so don't go by the name of the topic. Oh, no, I know percentage by heart. No. We'll see what kind of problems you are coming across, and then look at how do we decode the problems to solve it in the most appropriate, most time efficient, and more accurate way. All right? Everybody okay with the speech I gave? Samriddhi, Vivan, everybody? All right. All right, and I have done my marketing stuff, saying, okay, guys, whenever you get a chance to come to the classroom, please do so, because that gives us a great opportunity to interact better. Now, again, as you guys know, I have problem with my memory. My memory has never been so very friendly with me since my childhood days. So I always lean on concepts. Now, today we are going to talk about unit conversion in percentages. Hey Vishal.
Hi, sir.
So we are going to talk about unit conversion in percentages. What do we mean by unit conversion? Any going in thoughts around it? Yep.
Converting between like different measurements here.
Okay. Converting between different units of measurement. Okay. Hello, Tony. So we are talking about unit conversion, and we'll talk about percentages. So first thing I was saying, okay, what do we mean by unit conversion? And the definition that I heard from Praneeth is, it's about converting between different units of measurement. Now let's kind of break it down. Are you guys with me so far? Everybody? Can everybody hear me okay and see where my finger is moving? All the corners of the board. I know Praneeth would be very quick in saying yes because he doesn't have a problem there, but everybody else on the screen. Okay, all right. So when we talk about unit conversion, like you guys all know, let's look at it. If I talk about the distance from my house to Praneeth's house is 7 miles. All of you, hi Davik, all of you who have seen other units of measurement, you know that you can measure the distance in kilometers also, which is as per the metric system. Yeah. So if I want to say, okay, I know in miles it is 7 miles between the distance between my house and Praneeth's house, how much is that distance in kilometers? then you will say, okay, I think 1 mile is equal to probably 1.61 kilometers. So if the distance is 7 miles, if I have to convert that into kilometers, I'll multiply that by 1.61. So whatever is the mile, multiply that with 1.61, and whatever you get, that will be the value in kilometers. That's an easy one, correct? Everybody okay? Now, let's see if life remains so very easy always, and actually indeed it is easy. Sometimes we complicate it. Now let's say I have a cuboid whose dimensions are 5 inches is the length, let's say 8 inches is the width, and 12 centimeters is the height. And somebody says, find out the volume of this cuboid in cubic inches. What would come to your mind? I'm not wanting to get an answer for this one, but if somebody says, find out the volume of this cuboid without telling you whether in inches, cubic inches or cubic centimeters. Hi Dave.
Yes, sir.
Are you guys getting the question that I'm asking here, or trying to ask here? Let me repeat myself. We are talking about unit conversion, and we said, okay, when we change the measurement of unit from one system to another system, meaning metric system or US customary system, and we switch between them. When I'm talking about distance in miles, I can convert that to kilometers and calculate. But I'm saying it will not remain as simple as that. Here I have a cuboid where the length and width is given in inches, wherein the height is given in centimeters. So if this kind of situation that you're dealing with and you have been asked to find out the volume, first thing you will do is you will unify all the units. Meaning, if I have 2 dimensions in inches and third one in centimeter, I will make all possible attempt to convert this centimeter into inches. That means I need to know the relationship between inches and centimeter. In most of the circumstances, you guys, what I've seen is, you guys are given this conversion also, saying 1 inch equals 2.51 centimeter. You guys are given this kind of a conversion rate. Then you say, okay, if it's 12 centimeter, how many inches it would be? If I had 2.51 centimeter, that would have been 1 inch. I have 12 centimeters. So how much is that in inches? And you will convert that. Okay. Similarly, when you talk about unit conversion, you might have to convert within the same unit also. Let's say if you're talking about a length given to you in feet, and you have been asked to find out outcome from this using yards, then you have to know how is feet related to a yard. And this is just an example. So let's go back to some basics that we need to know, and then I'm not going to tell you guys the conversion formula because I myself don't remember that. As I acknowledge that my memory has been weak since my childhood days, so I would not dare to do that. But at a high level, you would know that there are 2 systems that we deal with. One is called the metric system, and one is called the US customary system. What are the things that we measure? We measure distance, we measure volume, we measure weight, and we measure time. Nowadays, you can also add one more dimension to it, say, okay, we also measure money. Yeah? So there are total 5 things that you measure. When you are measuring distance, volume or weight, time and money, thankfully, let's say if you are using one currency, dollar, we are using across both the systems. Time again, minute, seconds, hours, days, weeks, same way. But between distance volume and weight or mass. You have different units used. Here you use miles, inches, feet, yard. This is metric system. So here you use miles, yards, feet, and inches. Here you use centimeters, meters, millimeters, kilometers, whatnot. Okay. Similarly, if you're talking about volume, here you measure things in liters, liters, milliliters, centiliter, kiloliter. Here you measure in gallons, pint. Yeah. Similarly, when you are measuring weight in customary system, you will use weight as gram, kilogram, milligram, decagram, decigram, grams, kilograms. Here you measure weight as pound, ounce. No, and again, when you are measuring weight, measuring weight here you will use pound, ton, what else?
I think it's ounces.
Ounces, yeah.
Yeah.
So I'm not going into that because after seeing all the different types of problems that you deal with, most of the times you are given the conversion formula, so you don't have to memorize it. So I'm not putting effort for doing that. I'm just telling you guys that when you see different systems, this is what it means. And they are the 3-4 parameters that we measure using these units of measurement. If you are measuring height, you will not measure height in tons. You will measure that in feet and inches or in meters, whatever. Okay? Was that a good jump start? Riya, Ananya, Arush, Dave, everybody okay? Ritika okay? So, let me stop blabbering here and jump on to actual problems that you'll come across or deal with. And only one formula will work for us, and that formula is Praneeth's most favorite formula, that is because unit conversion percentage, there is no new concept that will come across. There will be nothing conceptually difficult for you to deal with. How you are reading the word problem, how you are interpreting it, how you are analyzing your approach, and then how you are doing it is what will make the answer go right or wrong. So we'll keep using this for solving it. Tony, are you with me, beta? Tony, can you hear me okay? Where is Tony? Yeah, Tony is there. Nikhil, Arush, Davik, everybody okay? Alright, so let's look at some interesting problems and see what is that we have in store for us. Let me read the first question for you. The great snipe is the fastest known migratory bird. The great snipe is the fastest known migratory bird. Scientists found that the bird can fly non-stop for approximately 4,200 miles. Okay? If the bird's speed is an average of 98 kilometers per hour, how many hours can the great snipe fly without stopping? So let me just put down some numbers so that you don't have to struggle with the numbers. Says the great snipe is the fastest known migratory bird. So there is a bird which is the fastest known migratory bird. Scientists found that the bird can fly non-stop for approximately 4,200 miles. If the bird's speed is an average of 98 kilometers per hour, how many hours can the great snipe fly without stopping? Everybody heard the question? So this is the maximum distance that she can cover non-stop, and this is the speed. So now we have been asked to find out how many hours the bird can fly without stopping. And that, like I was saying, that for you guys, it's always the conversion formula is given. It says, round the answer to the nearest tenth. That's the expectation. 1 kilometer is approximately equal to 62 miles. Did everybody hear the question? I will now, since you guys have the numbers in front of you, I'll just read it one last time. I know I might sound a little annoying, but I'm just trying to make sure everybody gets it right. The great snipe is the fastest known migratory bird. Scientists found that the bird can fly non-stop for approximately 4,200 miles. If the bird's speed is an average of 98 kilometers per hour, how many hours can the great snipe fly without stopping? And we have to round it to the nearest tenth. And also another information we have is 1 kilometer is approximately equal to 0.62 miles. Everybody clear, right, about the question? We have to find out how many hours he can fly, the bird can fly without stopping. And I will let you guys juggle with this. Dheera, are you clear, beta?
Sir, I got the answer.
You got the answer? How much it is?
Yep. This is 69.1.
69.1 what? 69.1 hour?
Yeah, hours.
Hours, okay. Okay. Riya, Samriddhi, everybody got the question right? Yes, Vishal.
I got 69.1 too.
Okay, alright. Saranya, how about you, beta? Yes, Davik.
I got 69.1 hours.
Okay. Praneet, you got the same?
It's just the calculations.
Okay.
They're using the calculator, so.
Okay. You approximately you can find it out.
Yeah.
Sarah, Neil, how about you guys?
I'm still working on
Okay, okay. How about Vishwa? And Vivan?
I got it, sir.
You got it? How much?
I don't know the answer. I'm still doing.
Oh, okay, you got the question. Okay, okay, alright. Jenna, Ananya, what's up?
I got 69.1.
I'm sorry, but your voice is quite feeble.
I got 69.
69.1? Okay. Hey, Tony. Are you able to hear me okay, beta? Tony?
Yeah, I can hear you now. My computer died.
Oh, okay, okay. So, did you get the question or you would want me to repeat the question for you?
Sorry, can you please repeat it?
Yeah. So, I'm just reading it and then you have some numbers on the board. The great snipe is the fastest known migratory bird. Scientists found that the bird can fly non-stop for approximately 4,200 miles. If the bird's speed is an average of 98 kilometers per hour, how many hours can the great snipe fly without stopping? 4,200 miles he can fly without stopping. This is the average speed in kilometers per hour. And then we are given also another information which says 1 kilometer is equal to approximately equal to 0.62 miles. So we have been asked to find out how many hours the bird can fly without stopping. Did you get it?
Yeah.
Okay. I will give you guys a minute and a half maybe. Everybody, and then I will show you guys my simple and less intelligent technique. How much you got? Same. Ananya, what did you get, beta? Nanya, Arush, Davik. Davik already told me. Okay. Nanya and Arush, what did you get? I I hope you guys are not upset with me after attending one class yesterday. Yes, Vishwa, go ahead.
We're trying to find how fast you go in 1 hour, right? For miles per hour.
No, so we are already been given the speed, 98 kilometers per hour. Okay, so let me just do it in my
So
yeah.
we're trying to find out if you was going in miles, how fast you would be.
No, so now let me try solving it. Okay, so just in the interest of time, so that we can deal with more problems today. So what we are given is, we are told that it's a bird which can fastest moving migratory bird. It moves at a very fast speed. We don't have to worry about that thing. What we are told is the bird can fly for 4,200 miles non-stop. Starts, fly that much, then it will stop if there is a need. This is the maximum distance it can go. And then we are given that it flies at an average speed of 98 kilometers per hour. So it can fly this much distance and flies at this speed. We have been asked to find out how many hours it can fly non-stop. So we know that how many miles it can fly non-stop. And we know the speed also. The only problem here is the distance that it can fly is given in miles, and this rate and the speed at which it can fly is given in kilometers per hour. So we have to first convert what is the speed in miles per hour, and then divide the total distance by the speed, so that we'll get number of hours. Yeah? Does it make sense, everybody? So let's find out. So this is the distance it can cover without stopping. Now at what speed? This speed, or 98 kilometers per hour. But my distance is in miles. Let's convert this kilometer into miles first. So if we know 1 kilometer is equal to 0.62 miles. So every kilometer I will multiply with miles. 98. So 98 kilometer, I can write this as 98 into 1 kilometer. Yep. Now this 1 kilometer is equal to 0.62 miles. I'll put a 0.62 and then I can write a mile. So 1 kilometer equal to 0.62 miles. I just replace this thing with this. So now we got the speed, 98 into 0.62 miles per hour. This is the speed. Calculate it. So it becomes probably 62 miles per hour kind of thing. Okay, 62 or little less than that. I'll round it to 60. Okay, because you guys will have calculator. I don't have one, so I'm not stressing too much about getting the exact value. And we have to anyways get to the nearest 10th value. Okay, 69.1 or 69.2, whatever we get, if that is in the acceptable range, we'll be fine. Here, so we got the speed as 60 miles per hour, meaning if it flies for 1 hour, it covers 60 miles. How many hours it has to fly to get to this many miles? Okay? This is the speed. This is the speed at which it is flying. This is average speed. So So 60 miles per hour is the speed. So 60 miles it covers in 1 hour. How many? 1 mile it covers in what time? 1 over 60, this many hours. So we are talking about 4,200 miles. That will cover in whatever time it takes for covering 1 mile. Multiply that by 4,200. That is the hour that will take for covering that many miles, which gives me 6, 7, around 70, because I did rounding. When you guys calculate it, you get more accurate value. So that's why 69.1 seems right to me. Okay, because you guys use calculator and that. Okay, but is that okay to everybody? Biswa, Vishal, Nikhil, everybody okay, right? I mean, at least I sounded convincing, or I did not? Dheera okay?
Yeah.
Yeah. Dheera, Jana, Neil, everybody okay, right? At least I'm not misguiding you guys so far. Okay, let's move on to the next problem. So again, if you ask me, is this a difficult problem? Probably not. It's just about how you relate to it. Let's pick up some more problems and then we'll know. What happened, Tony? You getting kicked out from the meeting?
Yes, sir. My computer keeps on glitching.
Okay. So that's why I keep recommending kids to be in the classroom with me. Keep coming to the classroom more often, okay? Yep. Yeah. Anyways, you have a driver's license. You can drive to whichever place you want to go to. All right, let's move on to the next problem. A particular car has a fuel efficiency of 8 liters of gasoline per 100 kilometers. A particular car has a fuel efficiency of 8 liters of gasoline per 100 kilometers. Eight liters per 100 kilometers. What is the fuel efficiency in miles per gallon? Round to the nearest integer. A particular car has a fuel efficiency of 8 liters of gasoline for 100 kilometers. Meaning it takes 8 liters of gasoline to cover this many kilometers. The question is, what is the fuel efficiency in miles per gallon? Miles per gallon. Here it is 8 liters per 100 kilometers. We have to find out how many miles per gallon the same car has the fuel efficiency for. And we are told that 1.6 kilometers is 1 mile and 3.8 liter is 1 gallon. So I'm repeating the question one more time. The car has a fuel efficiency of 8 liters per 100 kilometers. We have to find out the fuel efficiency in miles per gallon. So your distance unit is different from kilometers changing to miles, and your volumes unit is also changing from liter to gallon. And this is the conversion rate given to us. 1.6 kilometer equal to 1 mile and 3.8 liters equal to 1 gallon. This is an easy one. If you guys finish it, then we'll jump on to percentage problems. But I want to see how you guys are doing it. Everybody got the question, right?
Sir, what
Yes.
does 3.8 liters convert to?
1 gallon.
Okay.
So that's the relationship between liter and gallon. So 3.8 liter is 1 gallon and 1.6 kilometer is 1 mile. Okay? Everybody clear about it, right? The question? I can go and take a quick 2-minute nap. Okay, I'll let you guys deal with it before I come back to bother you guys. Dira clear? Yes, Vishwa, go ahead.
So what are we trying to find out?
So let me read the question, okay? I will not give you any clue. I will let you guys come up with your own thoughts here. The question says, a car has a fuel efficiency of 8 liters of gasoline per 100 kilometers. 8 liters of gasoline per 100 kilometers. That's the fuel efficiency. Okay? Now it says, what is the fuel efficiency in miles per gallon? And then you are given the conversion formula. The relationship between miles and kilometers, relationship between gallon and liters. Does it make sense, Vishwa?
Yeah.
Yeah? Go for it. I mean, again, these are not difficult ones, but how we approach is very crucial. Saranya, Jana, Neil, Sahit, everybody clear, right? Vishal? Okay. Deal with it. I am giving you guys 3 minutes for solving it. And then I will solve it in my way, just so that you can validate your approach. And then we'll jump on to percentage. Let me check in the meantime if I can find some more interesting problems related to conversion. Yes, Vishal. What did you get?
Can you read it one time, like the conversion part?
The conversion part, 1.6 kilometers is equal to 1 mile
Oh,
and 3.8 liters is equal to 1 gallon.
okay. So what are we finding now?
So we are given the fuel efficiency of the car as 8 liters for 100 kilometers. We have to find out the fuel efficiency in gallons per liter. No, sorry, wait. Miles per gallon, my bad. So that's how we measure it. I mean, if you guys remember, in places like India where people will say, okay, what is the mileage that the car gives? Or people will say 20 kilometers per liter. Here, when we talk in US, we say, okay, my car's mileage is 35 miles per gallon. So we have to find out that efficiency here. Say, okay, how much the car runs for every gallon of gas. That's the fuel efficiency. Okay? Yeah.
About 50 miles per 2 gallons.
50 miles for
2 gallons.
So you have to, okay, so then you will divide that by 2,
Yeah, so that'd be
approximately 25.
25.
Okay, we'll see.
Because I had to do some rounding.
Okay. Yeah, I mean, obviously, so calculator will be there at your disposal. So you would certainly not want to waste your energy doing the calculation part. But yeah, at least if you are clear about the approach, that will be a boost. Okay, let's see. Yes, Vishwa, what did you get?
I got 2 miles goes to 60 gallons.
2
Oh, it is 2 gallons for 60 miles.
2 gallons for 60 miles. Okay, let's see. Ananya, how about you, beta? Ananya, Davik, Neil, Sarah, what's happening? If you guys don't start counting how many gallons it takes for a certain number of miles when you start driving, how would you fill your tank of the car? Tony, you got the question, right?
Yeah, I got it.
So Tony is the one who can appreciate this question more because she drives a car and she knows what fuel efficiency means. She uses it practically. Yes, Davik.
I got 30.
30, approximately 30. Okay, so let me not stretch this question a lot so that we can spend some time with the percentage problems also. If and again, whoever is halfway through, you can probably pay attention to what I'm doing, so that way you can just tick mark whether you were going the right direction or you were doing it slightly differently. So this question says we are told that the fuel efficiency of the car is 8 liters for 100 kilometers, meaning it takes 8 liters of gasoline to drive a distance of 100 kilometers. Okay? Now, how much it goes in 1 liter? 100 by 8? Yeah? 8 liters for 100 kilometers, so 1 liter will go for 100 by 12.5 kilometers approximately. 100 by 8 is 12.5 kilometers. So basically, at a rough level, we got that 1 liter of gasoline is enough to go 12.5 kilometers. What we have been asked to find is, find the fuel efficiency in miles per gallon. This is kilometers per liter. 1 liter, this many kilometers. So this many kilometers for 1 liter. Now we have to convert that into, so here the fuel efficiency is 12.5 kilometers per liter. This is what we got. Now we have to find it out in miles per gallon. So kilometer has to be replaced with a mile, liter has to be replaced with a gallon. So look at this, it's very simple. 12.5 kilometer. I will write this as 1 kilometer. Per liter, I'll write this as 1 liter. Okay? Yes, Vishwa. I'm sorry?
1 gallon. I don't know, 1 gallon is 30 miles.
30 miles. Okay, we'll see that. So now I got this whole fuel efficiency in as 12.5 kilometer per liter. Now every kilometer I will replace with mile. I will see how much is 1 kilometer in miles and how much is 1 liter in gallon. Look at this. 1.6 kilometer equal to 1 mile. 1.6 kilometer is equal to 1 mile. So 1 kilometer will be equal to 1 over 1.6 miles. Yeah. And this guy here 3.8 liter equal to 1 gallon. So same way 1 liter will be equal to 1 over 3.8 gallon. Yeah. Look at this. I have 1 kilometer, I replace this by 1 by 6 miles, and this 1 liter I replace that with 1 by 3.8 gallon. So let's do that. And you guys will see some dance on the screen. I will make the numbers dance a little bit. So 12.5 divided 12.5 into 1 kilometer. It becomes 1 kilometer equal to how many miles? 1 by 1.6 miles divided by 1 liter. 1 liter is in how much in gallon? 1 by 3.8 gallon. Okay. So we got 12.5 into 1 by 1.6 by 1.38 miles per gallon. So what we'll do is, yeah. So whatever we have here, miles per gallon is fine. This number that we have, 1 by 1.6 divided by 1.38. Let's find it out. I will do multiply this. 3.8 goes here and 1 comes down. I can knock it off. So this part 1 by 1.6 and 1 by 3.8 became this value. It's like 38 by 16. So 12.5 into 38 by 16 miles per gallon. I mean, again, you guys might have a better approach for doing it, but I'm just doing it in a crude way. Okay. So 16 by 38 is 16 2 ja 32 and then 6.6 60 16 4 16 3 ja 48. So 12.5 into 2.3, whatever it comes, it will be little more than 38 liter. 60 to 32 6 16 3 ja 48. Yeah, 12.5 to 2.3, approximately 30. Whatever it is, I will leave it there. And again, don't get stressed out by what I'm doing here. Simple thing is, we got the fuel efficiency in kilometers per liter. I'm converting this 1 kilometer into miles. So every kilometer is 1 by 6, 1.6. That replaced with the miles, and 1 liter equals 1 by 3.8 gallons. So we replace the liter with this one, and that should be it. So, and from that, whatever the calculation you will do, and you will find it out. So I will not stress on how you get that, because you know that if you have 12.5 into 1 by 1.6 divided by 1 by 3.8, you will know how to calculate it and find it out. Is this part clear, or I am getting you guys little worried? Ritika, Jana, Ananya, is everybody okay? Tony okay? Okay. Dave, Dheera, everybody okay? And don't say okay just because everybody is saying okay. If you have a question, there is no question as a bad question. Okay. Now let's move on to the next topic, which is percentage. And again, I know percentage is something that is known to you guys for at least 20 years. Nobody is 20 years here, right? Except me. About 20 years. I mean, he was much about 20 years. But yeah. So I was just cracking a regular dad joke to wake you guys up. But percentage is something that you guys know. Percentage for me has two parts to it. When you have a number and you have to find out X percentage of it, or you have a number, you're trying to find out that is what percentage of another number. You have a number, let's say this is the money I have and this is the money that Davik has. I'm trying to find out my money is what percentage of Davik's money. So my money divided by Davik's money times 100, whatever comes, that is the derivation of my money is what percentage of Davik's money. So whoever is in the contention against which number times 100 is what it gives you, right? And again, I'm not decoding that in the simple way like I do it for younger ones, but I'm assuming that you guys are clear. So if you have a number, let's say 500, and we are trying to find out 25% of that. So 500, 25% of that number. You find it out. And you guys know how to do calculations, so I'm not going there. Now let's look at some legitimate problems on percentage, and then we will see which way we are going. But is everybody okay with that percentage concept, or anybody has slightest of the doubt? Yes, Jenna.
Do you think you can explain what like a part over whole relationship is, and then like you have to multiply by 100 or something?
Yeah, let me do that. I'll take probably 2 minutes. So percentage calculation is nothing but it's English for me. Like I keep insisting on the fact that English is mother of math. So if we understand the English part, okay, math will be relatively easier. So somebody says, find out 60% of 900. Okay? I will not look at any formula for this one. I will think of this like English. Okay? If I say 5 miles per hour, how do I write 5 miles per hour? This is a per. Okay? Similarly, cent is a short form of century, which stands for 100. Right? This is 21st century. Yeah? So 21 into 100, 21st century. So we will use the same English, okay? So I've been asked to find out 60% of 900 is how much? I'll use English. 60% of 900. That's it. So here you can play. Trailing zeros you can knock off. So you have 2 trailing zeros here, 2 trailing zeros here. You can knock them off. 60 into 9, that gives you 540. So we found out 60% of 900 is this much, and without memorizing any formula, we just thought of that as an English. 60% our century of, into is nothing but of, right? Of this. Done. Now, somebody says, I have 2 numbers, let's say Jenna and the teacher. So Jenna, let's say Jenna is, again, with no offense meant here, okay? I'm saying, let's say Jenna is 15 years old, okay? And the teacher is 50 years old, okay? We are trying to find out Jenna's age is what percentage of teacher's age. So Jenna's age is what percent of teacher's age. Okay? Now teacher's age we know is 50. So 15 is what percentage of 50? Whatever we don't know, we give it a name. Let's say X. So I'll convert that into a language saying 15 is X percent of 50. Is so far okay? I'm only playing with English so far. Jenna, are you okay with her? Okay. Now, 15 is X percent of 50. Let's find it out. 15 is X percent of 50. So we are saying X percent of 50 equals 15. Whatever I have written in English, I converted that to a formula. Again, reading formula. So here, if I want to keep only x on this side, let's do one by one. X into 50, meaning I'm moving 100. So if it's division at the bottom goes to the top and becomes 15 into 100. Now if I want to only keep x, because that's what we are trying to find out, what percentage? If I want to keep only x here, that means I have to move 50 also. And again, this moves from top, it will go to the bottom. So 15 into 100 by 50. What do you see here? X, which is not known, became 15 over 50 into 100. That becomes a formula for us. That if you have two numbers that you are trying to compare, this number is what percentage of this number? So you put the number that you are trying to figure it out for at the top as a numerator, and against which number at the denominator times 100. Look at this whole journey. We started with a very contentious thing. Yes, Jana, tell me.
So would your part be like the 15 and the whole 50?
Exactly. It's part and whole actually. Yeah. I did not use the part and whole terminology. I was trying to stay away from the formula and use it like English. What we are saying is, a number is what percentage of another number. We assume that is x. A number is x percentage of this number. So x percentage of a number is x percent of a number is this. We assume this to be x and we are trying to derive the value of x. So relating to what you are saying, same thing. A number which is a part, what percentage of the whole? This is how you can derive it. Part by whole times 100. And again, we just went through the story that I was boring you guys with. Yeah? Jana, is that clear, beta? Tony, Davik, Saranya. Am I making sense to everybody? Nikhil? Everybody? Okay. So that's why I'm saying that I, being a lazy guy, I try to refrain from forcing you guys to memorize formulas, because that's where I get stuck. If I'm telling you to memorize a formula, I have myself done a horrible job when it comes to memorizing formulas. So that's why I'm not preaching what I have never practiced myself. And in a way, though I'm giving all bad examples, but the fact is, formulas are not to be memorized, they have to be understood. If you understand the formulas, we can toy around with that in different ways. If we go for memorizing formula, there is a likelihood of me missing some formula, some term in the formula on the fly, and then everything starts flying around. Yeah? Like a plane flying to disturb us right now. Okay, alright. Is everybody okay so far? We have only 10 more minutes left. Let's see if we can deal with one percentage problem real quick. A store holiday sale has an item marked down by $10. A store holiday sale has an item marked down by $10 with an additional discount of 25% of the new price. If the final price was $36.27, what was the original price? Let me read the question one more time and put down some numbers on the board. Then you guys can relate to it. A store holiday sale has an item marked down. There are words that will mean a lot. You have to keep a note of that. A store holiday sale has an item marked down by $10 with an additional discount of 25%. This is additional discount. of the new price. This additional discount of the new price. If the final price was $36.27, what was the original price? Everybody heard the question? Biswa, Nikhil, Neil, Sarah, Sahit, Davik, everybody heard the question, right? Arush, Nanya? Dave? Okay. Just summarizing it, there is a sale going on in the store during the holidays. We are approaching Thanksgiving, so obviously that is very normal. The store sale has 10% markdown and an additional discount of 25% on the new price. If the new price that the customer has to pay $36.27, what was the original price? So you guys have to find it out.
Sir, I think it's at 58.3.
58.3,
58.4.
58.4, okay, we'll see. Neil, Sarah, Saranya, what do you guys think? Doing it?
Yes.
Okay. I'll give you guys 2 more minutes to deal with it. Yes, Derek.
I got 58.36.
Okay. Dira, how about you, beta?
I'm still doing it.
Oh, okay. You are here, but you're not here. So sit on the chair till the class gets over. Without making any sound. The notebook, pencil, compass, bottle, nothing should fall. Yes, Dave.
I got 57.8.
57 point? Okay. Yes, Vishal.
I got 55.3.
Okay. Okay. Yes, Aranya.
I got 57.8.
Okay. All right. Nikhil, how much?
I'm pretty sure it's 57.8.
You're pretty sure? That means you did not do it yourself?
No, sir, I actually did, but I was.
Okay. No. So again, I was not trying to put you on the spot. My whole thing is, look at my thumb, how dirty it is. I want you guys to get your hands dirty, okay? That's the rule of thumb. Okay. Because if we don't practice, the chances of we being right or wrong changes. Alright? So, let me solve it. Okay, so let me try solving it. So all the kids from level 1, you guys are here but you're not here. We still have 3 more minutes to go. So what we know from the question is, you guys are here but not here yet. Go there, stay in the corner. The class has not started for you guys. No sound business at all. So we have a sale going on in the store that says there is a markdown of by $10, meaning everything, let's say if it's 100, it's marked down by 10. That means it's being sold for $90. And then it says and there's additional discount of 25% on the new price, meaning after the markdown. So, after the markdown plus 25% discount, this was the price given. We have been asked to find out what was the original price. Whatever we don't know, in math, it's always safe to assume that is X. So, we are talking about markdown, X minus 10. That would have been the price if there was no other discount. Now it says 25% discount on the new price. This is the new price after the markdown. 25% discount. So you are buying it for 75% of the price. So 0.75 of that will be equal to this price. Do the calculation and you get it. So let's do it. So x minus 10 equals, this will go to other side, it becomes 36.27. I'll round it to 3 by 0.75. So this guy came down. So now 3630 by 75, and this will be somewhere around, let's see, 15 5 75, 7 5 35, 5 to the 10, 726 by 15, that is 15 4 just 60, 12 126, 15 8 the 126, 0.4. So x equals, this 10 goes to the other side, 48.4 plus 10, 58.4 should be the right answer. 58.4, 58.3, I mean, I did some rounding here, so that's why. I hope this was not that difficult a question. What I request you guys is, after I upload the video of the class, just watch it for 5-10 minutes, 15 minutes maybe, and then go to Khan Academy and try doing the unit test on percentage and the, what did you learn as apart from percentage? Unit conversion. So for these two units, just do the unit test on Khan Academy and see if there is anything that is bothering you guys or you are not able to solve by yourself. If that is the case, we'll meet again next week. Alright? With that being said, I'll let you guys go. Enjoy the rest of your evening. Just be aware that in the week of Thanksgiving, meaning right after Thanksgiving, that weekend we are not going to have class. I'll give you guys 2 days break, and I'll have break for myself also. Yep. Alright. So see you guys in the next class, and then we'll see how things go from there.